In section 8.6, this is our last new section from chapter 8, unit 9, we're going to use proportions and similar triangles to solve some problems. Theorem 8.7b says that corresponding altitudes of similar triangles are proportional to the corresponding sides. Now remember that altitudes go from a vertex to the opposite side at 90 degrees. It's like a height of the triangle. So if we have corresponding altitudes of similar triangles, we can put those in a proportion with corresponding sides. For example, these are similar triangles. These are the altitudes that go from a vertex to the opposite side at 90 degrees, and we can use these to set up a proportion. And there's a couple ways to set these up. Remember that your proportions have to have something in common on the top of your fractions, something in common on bottom, and something about each fraction that's true. For example, I could do 12 over 3 because those are corresponding sides. That's the left side of both triangles. Since the 12 is from the triangle that appears larger, when I go to use my altitude, I need to use the 8 on top. 3 is from the triangle that appears smaller, so x goes on bottom. Then also, there's something true about both tops. 12 and 8 are both from the large triangle. 3 and x are both from the small. 12 and 3 are both left sides. 8 and x are both altitudes. The nice thing about setting it up this way is I can reduce the 12 and the 3 into 4 over 1. So I can reduce those and make it easier to solve. 4 times x is 4x. 1 times 8 is 8. So x is 2. And that's what we're looking for as the missing side. These are also similar triangles. Let's try setting this one up differently. This time I'm going to use the parts of the triangle. You can do 10 over x equals, now since 10 is the side that corresponds to that is 6. X is the altitude that corresponds is 4. Again, 10 and x are from the large triangle. 6 and 4 are from the small triangle. 10 and 6 on top are both sides. X and 4 on bottom are both altitudes. Again, I can reduce the 6 over 4, so I'm actually solving 10 over x equals 6 over 4. If we divide the top and bottom by 2, turns into 3/2. You don't have to reduce this, but it will make solving the problem easier. You'll have smaller numbers to work with. 3 times x, I'm going to go to the bottom, is 3x. 10 times 2 is 20. And we divide by 3, we get 20/3. 3 goes into 26 times without going over. That gets us to 18. We have 2 left, and we keep the 3 on bottom. Still looking at those altitudes, these are similar triangles. Please pause and try this problem. The reason I'd like for you to try the problem on your own is because then you can watch the problem be solved and make sure you're setting it up right. Please pause and solve the problem. Okay, let's go ahead and solve this one. A couple different ways to set this up. The 12 and the x are our corresponding sides. We could put those into one fraction, or we could put parts from the same triangle into a fraction. So I'm going to do 6 over 12. This is an altitude over a side. So for my other fractions, I'm going to do the altitude over the side. Again, 6 and 4 are both altitudes. 12 and x are both sides. The 6 and the 12 are from the large triangle. 4 and x are from the small triangle. You could also do 6 over 4 equals 12 over x, and you will get the exact same answer. I'm going to solve this first one that we wrote down. I'm going to start by reducing my 6 over 12. If you didn't reduce your 6 over 12, you'll still get the same answer, but it just makes the problem easier because you have smaller numbers. So we're going to divide the top and bottom by 6. So we get that 1/2 equals 4 over x. So 1x equals 8. Remember, you don't have to divide by the 1. That just means that x is 8. Theorem 8.7c says corresponding medians of similar triangles are also sides. Remember that medians go from a vertex to the midpoint of the opposite side. So for example, these are similar triangles. We have some medians. This is going from the vertex to the midpoint. I know this is the midpoint because the sides are marked, the opposite side. Here also, it's going from the vertex to the midpoint of the opposite side. Now, you can either set this up that each fraction is the parts of the same triangle, or you could do corresponding pieces in the same triangle. So I'm going to do 9 over 3. That's a side over a side. equals, since the 9 is on top and that's from the large triangle, I must put the 8 on top from the small triangle. So 9 and 8, the tops are both the large triangle. 3 and x, the bottoms are both the small. And then there's a correspondence or something that's true about each fraction. 9 and 3 are both left sides. 8 and x are both those medians. Again, I could reduce my 9 over 3. If you did it, you still get the same answer, but I'm going to divide both of these by 3. So 3 over 1 equals 8 over x, and it just makes it a little bit easier to solve. So 3x equals 8. Be sure you cross once, bring down your equal sign, cross the other direction. And we divide, we get 8 over 3, which is the same thing as 2 and 2/3. And I would take either one, 8 over 3 or 2 and 2/3. Those are the same answer. Let's try another one, finding the value of x. These are similar triangles. So I'm going to do 12 over 9 because I noticed that 12 and 9 will reduce. Let's write it up here. And that's going to equal, since I did 12 over 9, both left sides, big over small, I'm going to do 2x plus 2 over x plus 4. Again, I can only reduce in the same fraction, so I'm going to divide 12 and 9 by 3, and I have 4/3. Also remember that if you have a plus or minus, you have an expression, you're going to put these in parentheses to cross multiply. So we're doing 4 times x plus 4 equals 3 times the 2x plus 2. And I put parentheses, I'm going to distribute. So 4x plus 16 equals 6x plus 6. And then we're going to solve. So to solve this, I'm going to subtract my 4x from both sides. Get all my x's to the right. Now you can move your x's to the left. You'll just have to deal with the negatives. And move all my numbers to the left. 16 minus 6 is 10. That's equal to 2x. And if we divide, we get that x is 5. So you just want to make sure you get the parts in the correct order. Go ahead and pause and try this problem. Remember, there should be a relationship between the tops, a relationship between the bottoms, and something true about each fraction. Pause and try this one. Okay, so if I set this one up, I'm going to go ahead and do 9 over 15. Both parts of the large triangle equals 9 is the median. So we're going to put x, the median, on top, over 12. I'm going to reduce my 9 and 15 by dividing by 3. So I have that 3/5 equals x over 12. When we cross multiply, 5 times x is 5x. Bring down your equals. 3 times 12 is 36. And when we divide by 5, we get that x is 7.2 or 7 1/5. I would take either answer. So theorem 8.7 says that the bisector of an angle of a triangle divides the opposite sides of the triangle into segments that are proportional to the two other sides. The bisector of an angle, so a segment that cuts the angle into congruent parts, divides the opposite side of the triangle into segments that are proportional to the other two sides. Let's look at an example of this. So here we have segment BD is a segment bisector. Segment BD is an angle bisector. So it's bisecting this angle. These two parts are the same. And it's going to cut this other side into pieces that are proportional to these other two sides. So I could do AD over DC, left of the bottom, right of the bottom. And then when I set up the other fraction, I do left side over right side, AB over BC. So we're going to do left part of the bottom, right part of the bottom, left side, right side. You could also do the left side of the bottom, the left corresponding side, right side of the bottom, right corresponding side. But we're going to kind of stick with this one for now. So I know that AB is 8. This piece is 8. From B to C is 12. DC is 7. And I'm looking for AD, so I'm going to call that X. Again, we're going to do AD, so X divided by DC. So DC, so X over 7, left over right, and that's the parts of the bottom. And we're going to set that equal to a ratio of the sides. We're going to start with the left side, since we started with X, and do 8 over 12. Now, 8 over 12 does reduce, and if you can reduce this, it will make your problem faster. You'll have smaller numbers. So I'm going to divide the top and bottom by 4 and use 2/3. X times 3 is 3x. 7 times 2 is 14. And when we divide, 3 goes into 14 4 times. That gets us to 12 without going over. And we get 4 2/3. Let's try another one of those. This time I know that AD is 5, BC is 11, DC is 8, and I'm looking for AB, and we can change which piece you're looking for. It just changes what you call X. So we're going to do AD over DC, so 5 over 8. We did left over right, so with our corresponding sides, we're going to do left over right, so X over 11. Cross multiplying, 8 times X is 8X, bring down your equal. 5 times 11 is 55, and you want to make sure when you cross multiply that you don't have fractions left there, that everything's multiplied out. Then we're going to divide by 8. 8 goes into 55 6 times without going over. That gets us up to 48, and we'll have 7/8 left. So X is 6 7/8, and it's okay to get fractions. Let's look at another one. This segment is an angle bisector, divides the opposite side proportionally with the remaining two sides. I know that AB is 12. I know that BC is 15. I know that AC, be really careful, this time we have AC is 20, and AD I don't know. Since AD I'm not sure about, I'm going to call that X. Now I need to look at the two pieces of this bottom side. So I have AD as X, I need DC. DC is whatever's left when I take this entire 20 and I subtract away the X. So you're going to do a whole thing minus the part that's used. 20 minus X, and we're going to solve the same way. I'm going to do AD over DC. So X over 20 minus X. I'm going to put that in parentheses. Left over right equals 12 over 15. Left over right. Again, if you can reduce it, we'll make it easier. So we're going to divide both the top and bottom by 3. So we have X over 20 minus X equals, dividing by 3 gives us 4/5. So when we cross multiply, 5 times X is 5X equals, and when we multiply by the 4, we're going to distribute. We're going to distribute the 4 through the 20 minus X. Dropping down, we have 5X equals 80 minus 4X. We're going to add the 4X to both sides. 9X equals 80, dividing by 9. 9 goes into 80 8 times. 8 times 9 is 72. 72 to 80 leaves us 8 more. So we have 8 8/9. And you could list the fraction or the decimal. That is fine. Let's look at one more kind of these. And then we'll talk about another theorem. Different kinds. We're also still going to do AD over DC and AB over BC. So I know AB is 8. BC is 10. AC, whole thing is 15. And this time, since I'm finding BC, I'm going to make that one X. Again, the other part of this is the whole thing minus the X that's used. So 15 minus X. We're going to go left of the bottom, right of the bottom. So 15 minus X, AD over DC over X equals, since we did left over right, I'm going to do the corresponding sides the same way, left over right. I want to keep that 15 minus X in parentheses, and let's reduce that fraction on the right by dividing the top and bottom by 2. So we get 4/5. Cross multiplying, 4 times X is 4X. When we multiply the 5, we're going to distribute that through the 15 minus X. So we'll drop down, and we get that 4X equals 75 minus 5X. Adding the 5X. 9X equals 75, and we divide by 9. 9 goes into 75 8 times. That gets us to 72. We'll have 3/9 left, which reduces to 1/3. So we get 8 1/3. Okay, we're going to start this problem over because I just hit the pause button. Again, I know that DE and AC are parallel. And to use these pieces, it needs to be the top and the bottom of the sides that those parallel lines touch to be able to solve this. So we're going to start out, we have that the left side, little piece over little piece, top over bottom, is 7 over 5. On the right side, I know the top part is 10. I'm not sure about the bottom part. So what we're going to do is we're going to take the entire length of the side, x, minus the 10 that's being used for the top. That'll give us what remains for the bottom. And I'm going to put x minus 10 in parentheses. Because when we cross multiply, we need to distribute the 7 through the x minus 10. 5 times 10 is 50. So distributing, we get 7x minus 70 equals 50. If we add the 70 to both sides, we get the 7x equals 120. Divided by 7, x is 17 and 1/7. And it's okay to get fractions. Now let's just look at a couple more. There's some different ones that come up, and we want to make sure that we talk about all the different types. Again, I'm looking at the left and right sides that the parallel lines cross through. DE and AC are parallel. I'm going to do the parts of the left side, so 12 on top. Over to find the bottom, you take the whole thing minus the piece that's used. 18 minus 12 gives me 6. Equals top over bottom, 9 over x. 12 over 6 reduces. If I divide those both by 2, I get 6. Oh, excuse me. If I divide those both by 6, I get 2 over 1. So we have 2 over 1 equals 9 over x. So 2 times x is 2x equals 1 times 9 is 9. And when you divide, x is 4.5. Okay, let's do one more of this kind. Let's do this last one. Again, DE is parallel to AC, and then I have one other type of problem to show you. Top over bottom, so 9 over, again, to find this missing piece, it's the entire thing minus that piece you know. So 15 minus 9 means this is 6. 9 over 6 reduces. We could divide by 3. So let's go ahead and make that 3 halves equals. Now I need top over bottom on the other side. I know the bottom is x. Again, to find the missing piece, you take the entire length of the side minus the piece that's being used. So 20 minus x. Cross multiplying, we get that 3x equals, and we're going to need to distribute our 2 through our 20 minus x. So we have 3x equals 40 minus 2x. Adding the 2x, we get 5x equals 40. And when we divide, we find that x is 8. Now I want to look at these other two problems to show you something else that happens. Even though I know that DE and AC are parallel, this time they did not give me those sides that the parallel lines touch. So these are split up differently. When this happens and you have kind of the parallel lines, what you're going to do is you're going to do the two individual triangles. So we're going to set up one ratio with the small triangle and one ratio that uses the large triangle. So my small triangle, I'm going to go ahead and do left side over bottom. So x over 8 equals, when we go to do the left side of the large triangle, it's this entire length, 6 over the bottom, 12. I can reduce the 6 over 12 into 1/2. So x times 2 is 2x. 8 times 1 is 8. And when we divide, we find that x is 4. So these are different. You need to use those pieces of the triangles, the left side and the bottom of each triangle. And you could have set this up differently. You can do left over left, but it has to be x over 6, bottom over bottom, 8 over 12. Okay, let's try this one that way. Let's do left side of the small triangle. So that's 8. Left side of the large triangle is actually 8 plus 2, so that's 10. Bottom of the small triangle is x. Bottom of the large triangle is 15. I can reduce 8 and 10. If I divide by 2, I get 4/5 equals x over 15. Cross multiplying, we get that 5x is equal to 4 times 15 is 60. Dividing by 5, we find that x is 12. So be really careful with these different types of problems. We could also use the converse of this. If you find that the line divides those two sides of a triangle proportionally, the left side top over bottom equals the right side top over bottom, then you can use the converse and say that that must be parallel to the third side of the triangle. In class, you'll be working on page 502 to 505, 11 through 28, and 41 to 46. You'll also need to work through handout 9A.